Okay, so in the last video, I worked through when the HCl was a limiting reagent. In this video, I want to work through what happens when the buffer is in the limiting reagent. So this is the buffer lab, the buffer experiment, part 2. And this is going to be when we add lots of HCl. So if we remember from our previous video, that the buffer system that we have is an equilibrium reaction of sodium bicarbonate with sodium carbonate. And the pKa of this equilibrium is 10.3. And so what we are doing is we are mixing 10 milliliters of the buffer. And this time, let's add 12 milliliters of HCl. And that is 1.0 molar HCl. And so the HCl is going to react with the carbonate in the system. And we have CO3 2 minus plus HCl goes to form HCO3 minus plus Cl minus. And so to start off with, I mixed enough buffer that gave me 5 times 10 to the minus 3 moles of carbonate and bicarbonate in the solution from the buffer. And then whenever I put 12 milliliters of 1 molar HCl, that gives me 1.2 times 10 to the minus 2 moles of HCl. This makes my carbonate the limiting reactant. And so that means that 5 times 10 to the minus 3 moles of reactants are going to react, forming 5 times 10 to the minus 3 moles of product. And so that gives me 0 carbonate, 7 times 10 to the minus 3 moles of HCl, and 1 times 10 to the minus 2 moles of bicarbonate left in the solution. And so this is where we need to think about what is in solution. And what we have in solution here is HCl, which is a strong acid. And we have bicarbonate, which is a weak acid. And this means that the pH contributions are coming from 2 places. But the main contributor is going to be the strong acid. And that means that when we have this condition, we get to ignore the contributions from the weak acid. And so this means that we get to find the pH of the solution the way that we would for a strong acid. And so we know that strong acids, when they are put into solution, they break up completely. And so if we started with 7 times 10 to the minus 3 moles of HCl, upon the total dissociation, we would have no HCl left and 7 times 10 to the minus 3 moles of H+. And from that, we can find the concentration directly. And so we know that the pH is minus log of the concentration of the H3O+, which is just another name for H+. And so the pH is going to be equal to minus log, and now I have to turn these moles into concentration by dividing by the total volume, which is going to be 22 milliliters or 0.022 liters. And so the pH is going to be equal to 0.50. Now remember that there's complications in this, and this will not match the simulator. But that is okay. It is because we are making an approximation that the simulator is not making. Okay, so I hope this helps, and keep sending me emails.